Good afternoon, everyone. Hope you're having a good day. My week was kind of interesting. Really excited about the start of the Olympics, so we've been watching a lot of that. Some great results for the USA already. Also, some fantastic performances from other countries I've seen. So really excited. 2 weeks of fun, and man, that opening ceremony was something else. But we are here to talk about Rust and about databases. So, welcome to the stream. If you're just joining in. So in the past few weeks, we've been working on this implementation of a storage engine called HanoiDB. And oof, that went really big over everything. And of course, I'd mentioned that my longtime colleague, Greg Bird, worked with him at multiple jobs. He was one of the co-authors on HanoiDB. And he's been giving me a lot of feedback. Unfortunately, he's in Italy right now, so this is kind of a late time for him, and dealing with kids and whatnot. So he can't really join. But he's been providing a lot of interesting feedback. One of the things that he suggested that we might look into today is, rather than using direct file operations, use mmap. I think my premise in the last stream was that we don't need that yet. And like our experience from Bitcask indicated that doing direct reads was fine, and the operating system is pretty good about managing the page cache. That said, at high volume, both in terms of size of data, number of keys, and traffic, like read-write traffic, there is potential there that we could thrash. So I want to take a brief look at what's available in Rust for mmap. And I don't know if there's something that is sufficient. One of the challenges there is that Rust tries to be really explicit about doing cross-platform things, and mmap, I don't know that it has a direct equivalent on, for example, Windows. Obviously, on Unix style operating systems, it's going to be there. But let's look into that. He sent me a link to a library from Cloudflare that does mmap. So we might look at the documentation for that and see if it's going to work for what we want. There's also a number of ones that are kind of out there on crates.io. They seem to have varying levels of quality. Some of them, are like haven't been updated in many years. That's not to say they're in a bad condition or not going to work, but they might not be the right choice, especially if they're not maintained. So let's have a look. All right. So Greg sent me this mmap-sync one, I think, and I was hoping. Yeah. Okay. So it is on docs.rs at least. Okay. So concurrent data access. So single writer, multiple reader processes using memory map files. So I think this is more about a synchronization type of use of mmap, but what we would want to use it for is memory mapped files. So let's look into that. If we don't end up picking this up this stream, maybe what we can do is pick it up in a future stream. And and then we can maybe do some interesting management of the memory there. Okay, so let's look at. So it offers memory map files. It also looks like it has some some Serde based on the archive library, which is a really cool library. I am not sure that we will go down this route yet. Now, if we try to go, like, take the principles of HanoiDB, if we get to that point, and make it more Rust-like, we might consider using something like archive and pushing down some of the complexity of reading the bits, out of the file. But for right now, I think we'll probably just look into, can we mmap read-only files? So let's look into that. Garma redact. Okay, so utilizing RA. Okay, fine. ReadGuard is the primary structure in this module. On creation, ReadGuard provides a reference to an entity in shared memory. This might be too full-featured. Really, we just want to map a file. Okay, so let's look at instance version synchronizer. Okay, maybe we need to look at the examples for this. This might not be. Yeah, this looks like using the file system, mmapped file system. And apologies, my window unit air conditioner just kicked on, so if that's too much noise in the background, I'm sorry. I'll try to stay with my mouth close to the microphone, so you mostly hear me and not that. Yeah, I get the feeling like what they're not exposing here is, like, I want to pretend that this file is a contiguous buffer. And this looks like on top of mmap, a synchronization. Let's see what their dependencies are. So there's mmap2. Let's look at that. Okay, so cross-platform for memory mapped buffers. Oops. Okay, maybe this is what we want. Okay, so correspond to mapping a file to a slice of U8s or mute U8. We're not going to do this immediately. We might do this in the nursery or in merge processes, but we'll find out. Okay, so both function by dereferencing to a slice, allowing the mmap to be used the same way you do equivalent slice types. Okay. So you do file open. Okay, so this is an unsafe API. So mmap, let's look into that. Let's look at that struct. Okay, so you have to open the file, and then mmap will handle that. Right, there's a potential for undefined behavior. And why is this? It's because, like, Rust is so focused on memory safety, right? And this is a low-level, like, kernel API, memory mapping a file. There's potential guarantee, like lack of guarantees, that the file will not be, like, ripped out from underneath you. I think it really comes down to, in Rust, you can't guarantee that because it's not managing the memory, right? They're saying here they're all marked unsafe because of potential undefined behavior using the map if the underlying file is subsequently modified in or outside of the process. Applications must consider the risk and take appropriate precautions using file-back maps. Solutions such as file permissions, locks, or process private files exist, but are platform-specific and limited. So, like, maybe on a Linux machine we could use one of these, but that might not be available in some other platform. So let's have a look at this. Okay. This is an example they gave. I love it when they give examples in their docs. It's very, very useful. Okay, so I guess you could potentially open a file read-only and then move it to write. So this is the other thing that Greg suggested is that we give, this is kind of hinting to the operating system about where we're going to try to read next. So let's look at that advice. And this is safe, by the way. Opening it, memory mapping it is unsafe. We can give advise range. Now it says it's only supported on Unix. What I don't see here, we'll maybe look at the source. Yeah, it's with config Unix. Okay, you can lock and unlock. We probably won't use this remap right away. Again, these are wrappers around syscalls, right? So we could look at the man pages if we're curious about what is the actual functionality there. Let's look at this advice thing. Okay, so this really comes down to the madvise man page. They say map page, that's probably typo. Okay, so we can kind of tell the operating system we're about to do this. Now, random means we could jump to any point in the file. I think with this, we'll want to advise something like maybe sequential. Should read the man page. If this is just copy paste from the man page. Hi Isaac, welcome to the stream. Thanks for showing up. Okay, so we're kind of, this is like advice about what our intentions are for a particular range of the file, right? This is complicated. We might punt on this because I think I want to do some things like, like what we did for BDB, like read a single key or iterate through the keys in a tree. That might be more interesting before we actually tackle the mmap. Okay, so we could make use of this. I'll bookmark it. Just let's see here. We don't want that. We want this crate. Is this the latest version? Yes. Okay, so we will move this into our bookmarks. Yeah, I was letting the poll run. So Isaac asked, are you still on Twitch? Didn't switch to YouTube. I didn't have time to set up YouTube streaming today. We'll do that next week. It was pretty convincingly everybody wants YouTube. That's where they find their content. That's where they look for content. It makes sense for me to stream there. So I'll be next week. What I'll probably do is do a short blurb on Twitch going, hey, I'm moving to YouTube. Here's the link. And then we'll start the actual stream on YouTube. So watch out for that. Okay, so this is good to have. I think we'll tackle that next time. Let's get our code up. So if we look at what we did last time, so we were not reading the whole file, right? We switched it to read from file handles instead of loading the whole thing, right? And it looks like my my commit message got truncated there. Okay, so I think it might be time. Yeah, let's look into looking up like an individual key. That might be interesting. Yeah. Thanks, Isaac. Please do keep an eye out. I will probably, because YouTube allows us to announce a stream before you start it. I'll probably start doing that. I have not been very good about cover thumbnails on YouTube, so I'll probably make one for that announcement, so you don't have to look at some random thing of my face and a code editor. But yeah. Okay, so we kind of have this tree idea. It's a single file. We haven't built in any concept of the levels yet. But we will want to be able to find a key in a specific file, in a specific tree. So let's figure out how to do that. Maybe do it the dumb way first, right? We will. So we have the tree. We have the ability to get a block, and the block gives us an entry iterator. So we do have some complications like we did in BDB about what level are we at? Do we do we even care about that? We'll probably want to do something like that. So let's just get, rather than giving an iterator of all the entries in the tree, let's just try to make one that gets a particular key. And this is self. And then a key is going to be a slice of U8. And this will return an option. Hi, Chris. Welcome to the stream. So we want to get the value. Now, there's a possibility here that we could return something like this was a tombstone, so this was deleted, or this was expired. But we're not going to do that yet. Let's just see if we can return a U8. And then we'll get to maybe do something more interesting later. Okay. So we're going to try to see if a key is in there. Now, there is a to-do here, right, which is read the Bloom filter and bail early if it's not in the file. Obviously, it's going to be challenging to have something that's actually compatible with the Erlang Bloom filters, so we're probably just not going to bother. When we get to writing files ourselves, what I would like to do is, bump the magic here, do like HAN3 or something like that. And then we can store, we can store a Bloom filter. Another thing that Greg suggested was a succinct range filter called surfs. They look pretty cool. So we could potentially do one of those. The implementation in Rust doesn't have a direct serialization format, which is troublesome. We might need to use byte muck for that sort of thing. That makes me a little nervous, especially without like declaring a specific endianness for a file. That kind of makes me nervous. So we'll think about that. I was thinking that this might become, rather than just format, this might become v2, and we turn tree into an enum that has different, like expects different formats, and we could try to read, the format and then return a variant of the tree, and put those in different put the implementations in different modules, so you can, like, we can muck with the individual contents of the file. Right now we're just kind of focused on reading, so I'm not going to bother with that. But getting back to the thing. Okay, so we are going to say, let's make a block, and I'm making this mute so that we can reassign it when we're doing the traversal. So let's do self.root block. Okay, so that's going to give us the root block. Okay, and then we're going to we need to iterate over the entries, but we kind of need to do, why don't we just do a loop, and we'll have a bail condition, right? I say we know that if the level on the block, let's look at what block has. We know if the level is 1, or is it 0? I think it's 1, where we know that this is like a leaf. So maybe we just do if block.level greater than 1. We're going to loop through the entries, and then we're going to try to find one that we can pass to this function, right? And if we get some other kind of entry, then we'll maybe bail, return none, just as a safety measure. Okay, so if the level is greater than 1, then we know this is an inner node. Level equals 1. We know it's a leaf node. Leaf node. This is a leaf block. Let's say not node. Let's say inner block, right? That's more clear with our nomenclature. Okay. Let's do the, I'm just gonna return none here. Let's do the leaf one first. We're pretty convinced that the root node is not going to be a leaf, but that's a little bit more complicated. So let's take care of the let's take care of the leaf nodes. Okay, so this one is actually the easiest one. So we're going to loop over for block, let's see, for entry in block.entries, right? And we'll say if let entry key value is entry. So if we got an and we're going to return none here because we know we're in the leaf page that we should be in if we don't find it, right? So we're, this is a sequential scan. We're not doing any bisecting or anything. In fact, the file doesn't lend itself to that, to binary searching. It doesn't, unlike BDB, it doesn't have the pointers to the individual keys as different offsets inside the page. So anyway, okay. So we have an entry, and then we will say if key, and here we're shadowing. So let's rename this found key. Return some value. And yeah. Otherwise we just keep going. Now what's going on here? Okay, so we need to make sure that we do this, right? Now it's probably complaining, yeah, it's borrowed. We're not matching on timestamp, we don't care. Okay, the thing is, what we did when we read is we read this into actual. So I think we need to do evacuate so that value is returned, and now we've got problems. This loop never actually loops. Okay, well, for now we're not doing that. We're going to change that, but okay, I think we can ignore that for now, because we're going to do this right now. So what we're going to do for this one, I think this is, this logic is not great. I'm not happy with it. But we could turn this into like find map or something like that. Okay, so we need to give it a case where it's going to loop. We'll start with that, and then it's going to be like, oh, your block doesn't change, but it's going to. It's going to. I promise you. Okay, so we're going to say we probably need to do something like we did in BDB, where we're iterating over the entries until we hit one of them that's greater, and then we go seek out the previous one, right? We could do that with a for loop, I suppose. We could peek, we could do not windows, because that's only on slice. Let's look at iterator. We could search for the position. It might require us taking, like, exercising the iterator twice. I'd rather not do that. Chunks are nightly. Fun. Yeah. The other thing we could do is do take while. And get... take while the entry that we've got is less than the key that we're searching for. Okay, so yeah, let's do something like that. And then we want to take the last one, right? Yeah. Okay. So let's just go entries, block.entries, take while. And we're going to say this is some entry. And we'll do last. Okay. If let entry pause-len. This is a case where maybe a match is better, because like we were doing this down here and then we have this additional if. I kind of want to put a guard on it as well, right? We're going to ignore not key val. Pause-len. Okay. Key. Right. So actually what we want to do is if key is less than first key, we return false. And actually probably don't need the brackets there. We just need commas. Right? Because that's our stop condition, and then anything else will return true. We don't care about matching. And this I can probably, yeah, it's probably going to tell me that's too complicated. Oof. What's wrong here? Looks like a matches macro. Yeah, well, help me out here, Clippy. Change it to a matches macro for me. Okay, well, let's just rewrite it. So matches takes the pattern first. Come on. No, it takes the object first and then the pattern. So we'll do matches, and then we'll just pull this out. And we want it to not match that, right? what's wrong here? Okay, and we don't care about these other fields. Okay, so now this will be sum of an entry. Okay. This is, the problem is I think this is going to be an off by 1. Let me think about this again. Sorry for the bump on the microphone there. Okay, so what we want to take is all of the ones that are less than or equal to the key. Maybe I have too many negatives here. So, right, I want to take all the ones where the key... The problem here is if there's any other kind of entry, like, not that there will be in an internal page, but if it's not one of these where the key is smaller, then we want to return true. We don't care. And then we'll do something like this here. And we don't care about it here. Right? Then we're going to... I'm still not certain about this logic. It's bugging me. The match expression I felt more confident about. I think this is okay, because that is a compression of the thing that we had at first. Yeah. Okay, so now we need to do block is self.block from poslin entry. And we don't actually need to do that, right? In that case, we can do if entry is sum. This returns a result, so we need to do OK. If it can't read it, then we need to return none, obviously. It's starting to become a question in my mind whether we turn this into a result rather than an option. I think, like, option is the better one ergonomically. But since this involves file operations, maybe maybe result is okay. Okay, so if we didn't get an entry, now this also, if we go to this definition, note that if it's not a poslin entry, we're already covered there, and it returns an entry, or it returns an error. So it's fine to just turn that into a none, and they don't have to match on it. Okay, here we'll return none. Okay, so Okay, we're gonna do let sum inner entry equals entry, right? Because that was a optional entry, and we'll just borrow it there. Okay, made the compiler happy. Okay, so let's go over this real quick. Okay, so this is actually quite a bit simpler than the BDB one. And I think it has to do with, maybe a little bit more clarity in my head, but also a simpler format. Okay, so normally we would try to read the Bloom filter and bail early if it's not in the file. Obviously, we want to return that quickly, and we don't want to scan. Okay, so if we're at an inner node where the level is not 1, then we're going to loop over the entries. They should be poslin entries. If we get anything else, we're just going to say, yeah, fine, whatever. And we're going to try to scan them until we get get one where the key is bigger than the key we're searching for. And then we'll take the last one. So that's basically saying find the greatest one that is smaller than the key that we're searching for. That's how these indexed things work. Okay, so then if we did find one, so if there is one as part of this this scan here, then we will set the block to iterate down the tree into that subtree. So we're getting a new block, which is potentially another inner node or inner block. It might be a leaf block, but we'll start scanning that block of the B tree. Okay, so if it is a leaf node, if it is level 1, then we're just going to loop through the entries. And if we find the entry, we will return it. And I think I might change this up. We might do like find map. I think that would be better. Yeah, let's go ahead and change that to find map. I like that idea. So we'll say return. So we know we're in a leaf node, so it's either in here or it's not at all, right? Find map. And then we'll go, this is entry. Match entry. And we'll say entry key val. Key value, dot dot. Found key if key equals found key. Then we return some value, else we return none. And that's quite a bit more succinct, I think, than this loop that we first wrote. A bit more Rust-like as well. Drop something in the chat if that's confusing to you. I kind of like this. This isn't bad at all. So I'm going to put a little note in here, which is go to the next lower level in the tree. Okay, and what our main did previously was just loop through all the entries in a child block. So without doing this get, we could probably just run our program. Test. Okay, so we could construct something that we want to look for in this page. And let's search for like maybe this second one. Oops. And add that to our main program. Okay, and let's see. We're going to do tree get, and we're going to say key is back with that. And let's just let's result is that, and let's print line found key result. Okay, and let's see if we can run that again. Let's put something in here. Just a bunch of equals, and we'll say searching for key, and that way we'll have, you know, a break in our output here that we can scan more easily. Okay, so now let's run that again, and it did not find it. So we have okay, it did not find it. So we need to debug this. We confirmed up here, iterating through this, that yeah, we should get this key should be findable, right? Okay, so let's start to debug inner entry. Okay, and then let's do print line here, and say found inner entry, jumping to next level, and we'll debug the entry here, and we'll say no inner entries found, boarding, right? And here we'll go scanning leaf for key. And let's see what happens in our stuff here. Okay, so interestingly, it said it was scanning the leaf. What I did not see is, okay, so I think we have a bug here, and I think it's the root level 0, not 1. And we're gonna have to look at the original code and see what was going on there, because I think that we have a situation where it actually wasn't root level, or rather the root was not a leaf. Maybe let's look at the writer. It'll probably, interesting, that's integer and not non-negative integer or positive integer. Okay. Sorry, what I'm doing right now is just scanning the Erlang code to find out where it's incrementing the levels and whether it starts with 0, right? Or if it starts with 1. I don't recall what we figured out last time. Okay, so Level greater than 0. There's the answer. So we need to change our logic. Let me switch back to the Rust. So level greater than 0 is an inner block. And I think that we did that wrong. And so it didn't find anything. Of course it didn't find anything. Okay, so now we've got found inner entry pos_len. The block position is 4. The length is 8736. The first key is 97. And it says a scanning leaf. It found the key, and it actually did find it. So, okay, so we fixed a very simple off by 1 bug. Okay, cool. Pretty cool. So we now can probably remove these prints now that we're not concerned about the correctness of this algorithm. All right. What I would like to do now is we have the ability to read immutable trees. I think it would be good to look at the nursery, and give me just a second to close this other one that I don't know why it's open. Okay. Let's open that. Okay. Let's have a look at the Erlang code for the nursery. Now, one of the challenges here is that this is very much written as Erlang lightweight processes. We're not going to have that in Rust. We might do something with threads later. Since this is file system stuff, and like async is on file system, they probably won't be async. They won't be Tokyo tasks. And there's good and bad reasons to use Tokyo for this sort of thing. But let's have a look at the nursery. The nursery is where keys get written to when they're inserted or updated. The neat thing about LSM trees is an update is an insert, and the lower levels override anything found in the upper levels. So, okay, so they're saying do an incremental merge every this many inserts. This value must be less than or equal to 2 to the power of the top level. Let's look at, where's that B tree size? Oh, and I don't have my Erlang language server set up correctly still. But that's probably in HanoiDB.url. Nope, it's in this one. B tree size is, so level 2 to the power of whatever. That's number of keys, by the way. That's not bytes. Okay. So this is interesting in that it doesn't start a process. I think the nursery runs in the primary process that the app starts. It doesn't, because here it's, creating a new nursery just creates some data and opens the nursery log, right? Okay. Okay, so this is about recovering the nursery. Um, so if the file exists, then it tries to read the log and recover the log, and otherwise it just creates this record. Note the cache is at GB trees. We will probably use btree map. GB trees is a thing that would be used in Erlang before maps existed in the language. There's still potentially performance reasons to use GB trees. I think it scales to bigger stuff, but it does use more RAM in general. You've got all the accounting stuff that you wouldn't have to do with the built-in maps. Anyway, the other thing that it would give you is these are guaranteed to be ordered, and maps are not ordered in Erlang. So we'll probably use btree map in Rust for that. Okay. And so min level and max level, I think that's kind of just bounding the size of the database that you can store. Obviously, min level is like, here's where we're going to start. Yeah, I got to scale that big data, right, Chris? Min level is where we're going to start. Probably, I think the current example was 10. So 1024 entries in each in like the lowest level. I think that's a reasonable size. And then, max level, who knows what it is. I might have to search for that. Or if it's something you just set. I don't know. Yeah, there's no constant in here for max level, so we could do something similar. And these will use like, U32s or something for them. Okay, and we're going to have to see what this config thing is. There's no type specs on this, so I'm kind of flying blind here, except for these guards, right? Well, let's go look at HanoiDB util ensure expiry and see what the heck that is. Okay, so this is saying is this expiry in the options? If it's undefined, then print some stack trace goop, and then exit expiry seconds not set. Okay, so that's just like a guard on did you set this thing. That's kind of weird. I would expect, well, I guess you could say 0. Excuse me. Honestly, we don't care right now, so I think we can reasonably ignore that. Oh, you can use infinity. And I think that atoms are greater than numbers, and so it's fine. That's a little sketch. Okay. Yeah. It is neat though that like they built the ability for keys to expire into the data store. Then if you hit a key that has expired, then you can just treat it as missing, and then remove it when you merge. That's pretty awesome. We're not handling that right now, but let's go back and look at the nursery and see what else they do in here. So there's recovery logic. We'll need to deal with that, right? So Also, these modules have the weirdest APIs. It's not put and get, it's enter. Let's look at GB trees just to make sure we're not doing something silly. Okay, so this is a, insert it if it's not there. Otherwise, update the key. Effectively, that would be the same operation in Rust. Just feel like, just replace this thing. It, takes the value anyway. It owns it. Okay. And here they're saying if it's a tombstone, if value is a tombstone, we'll need to maybe think about how we store our entries in the nursery. That'll be pretty interesting. Okay, and then if you're past an empty thing, you just do this. This fill cache thing is probably used in the recovery. Yeah, read nursery from log. Well, let's move on. Okay, read nursery from log. I am not interested in promotions. Go away. Okay, so we're going to read the whole file, the log file. And it looks like there's like checking integrity of the keys, and then it's, yeah, okay. So then it's like, is this a list of key value pairs? Then go ahead and, read, start from an empty tree and entry GB tree and fill in the individual keys and values into this, and then that becomes the contents of the nursery. So this is recovering. That's what that fill cache is for. I honestly wish it weren't called cache. It doesn't make sense. It's like the actual data of the nursery. Anyway, and then it's returning the struct. So let's look at the add. This is the meat. Okay, so let's look at this. So do add says it takes the nursery that we created up here. It takes a key and a value, which is either, a binary or the tombstone sentinel value. And then it takes either non-negative integer or infinity. This is the expiration time. And so the PID, so this is probably, I don't know what top means here. We'll find out by reading this. And so basically if it's got an infinity, it's using 0. Fine. Okay, so then if there's an expiration, second set in config. Right, so this is individual key expiry time. Okay, so this is like a duration, it looks like. Okay, so this looks like they're taking the existing cache and then they're going to create a new entry with the CRC check on it. And they're going to insert that into the tree. And that, because everything is immutable in Erlang, you get a new cache, right? You get a new GB tree out of this. And you also get the individual entry. Okay, so if they're both set to 0, they're basically saying that there's no expiration. Otherwise, it's going down here. And if the database is set to 0, but the key... Yeah, we're going to ignore that. We don't care about the expiration right now. We just want to write some stuff. Okay, we're going to have to look at this function. I think we looked at it in a previous stream and we're really confused. It might make more sense now. Okay, so now that they've got this entry and it's in the in-memory cache, right? They're going to append it to the file, the open file of the nursery log, right? So log file equals file. So they're appending this binary entry to there, and then they're calling fsync on it. So this is what allows you to stop it in an incomplete state and recover. And then it's going to try to do an incremental merge, which this will be the interesting thing that we don't really know anything about yet. And it's looking like, okay, so this triggers a potential merge, and this is the size in bytes, I guess, total size, and then this number of entries is count, right? Still don't know what top is. It may reveal itself in this function. Okay, so then if it has room, okay, so it's going to either return okay, and here's the new nursery struct, or it's going to return full, and here's the new nursery struct. So this has room. We're going to have to find, but let's see if we can find this do inc merge. Do sync. Okay, so they're looking here at you can choose to sync, like call fsync basically after every entry, which is the default, or you can say every n seconds. And so they're just checking when was the last time, and has enough time elapsed to do a sync, and then if it did, then then we have a new timestamp. And so they're tracking when was the last sync time. All right, skipping lookup for now. Okay, so this is where they're writing this nursery into a B tree. That'll be interesting. We'll want to look at. Let's find that do inc merge thing. Okay. So top is the top level. Okay. So this is where they're starting to do some process communication stuff. So top meaning top level. Each of those levels, like, in our example database, we have, 11, 11, 12, 13, etc. We had 10 in our Rust one. We had 10 and 12, skipped 11 for whatever reason. But those launch as processes that own the individual files. So it looks like there's some step. I'm not sure what this step value is. We need to look at where it comes from. I think that has to do with are we pushing the system to continue merging? Yeah. And this is how many keys we inserted, I think. Okay, so if we... Right, so if the number of... Basically the number of inserts we've done, or updates, exceeds this threshold, then it's like, try to do this many merges. Merge operations. We'll have to look into what this actually does at some point. And then reset the number of steps back to 0. and record how many merges were done. Otherwise, just add it. So like if we're adding one key at a time, go away first time chatter, promoting something. If we're going one key at a time, you know, obviously this only goes up by one. Okay. We're going to ignore a fold. So you can set the max level. Okay, let's go back up a bit. We were looking at do add, which I think is not exported. It's add that's exported. Let's see. Add, right. Okay. Okay, so this is where the OK and full comes in. If the internal add goes, yep, we're fine, then it just continues. Otherwise, if it's full, the idea is to, that's saying all these entries in the nursery are going to immediately go into a new file that gets promoted to the lowest level. Okay, so that means you can truncate the nursery log after they're written. So they're saying finish this. So let's go look at that function. Finish. Fish. Okay, and this is okay. So this is flush the cache to a new B tree. This is writing nursery.data, which will then get renamed when it's passed to the first level, the top level. And then it's like, okay, right here, open this file with this file name. And this is the size. So looking at the min level, this is the size of the number of entries. And then this is one of the weird things about Erlang. It's not like you can just take all the entries out of that data structure. It's going, okay, fold over this tree, which will be in order, by the way, and then write the key and value into the B tree that is represented by this writer, and then close. And then this is they say blocking RPC. This is calling that top level saying, hey, I have a new B tree file for you. Here you go. And then, okay, so then it's like start to merge potentially. Okay. And yeah, and then it's going to delete the nursery log. So now that all this data that we've been collecting in memory and incrementally writing to that log is written to a data file, we can rewrite that log file. And yeah, it's interesting to use file delete here rather than truncate. I don't know if that's better or not. Anyway, so down here in flush, after it's called finish, it's like, make sure that file doesn't exist anymore. And then taking the data here out of the current nursery, then create a new nursery, and that's the result. Okay. So I think we have a bit that I'm going to leave this open so we can refer to it. I think we can start to make a new, but first let's make a commit here. Right. So this is session 4, I think. Search for a specific key in a B tree file. Okay. All right, so now let's go ahead and make a new module here, which is going to be the nursery. And we're going to do this. And we're going to use standard collections B-tree map. I think there's let's do a new function, a new method on nursery, so that we can create one. And this is going to have to take some of the same things that we saw up here. Okay. One of the things that we won't be able to do is to have this nursery directly communicate with the levels. There's going to have to be some other layer which does coordination between those things so that we can make them not care about whether it's threads or, you know, are we using channels or something else. Interestingly here, the you know, the log file is open with these options. I don't remember what exclusive is, but obviously, you know, raw, they're going to be writing raw bytes to it. It is open for write. Delayed write means, you know, let the operating system buffer it, and append only. So we'll want to capture some of those options when we open the file. Yeah, we're not caring about the config right now. So let's say, so there's the log is going to be a file. And I think the problem with this is we're not declaring it up here. Mod nursery. Yeah. So it's like, I can't compile that. Okay, so there's the log file. Directory is going to be path. Yeah. It can be path buff. The thing is, it's going to be asref path, so probably when we pass it. Okay, and there's going to be a min level. We'll use U32 and a max level. We could use usize. Could use U64, and then it might be easy to do the bit shifting. The thing is, I don't want to explicitly say usize because that would imply that maybe there's, you know, something indexable in memory by that value, and we're not really using it for that. We don't care about the config, and we're just calling it data as a B-tree map. And we need to figure out what the keys and the values are going to be here. So I want to look back at this, and there was a thing in here where it was CRC encapsulate KV entry that we saw earlier. And there's sort of a question in my mind of, yeah, okay, so this is kind of funky. They're turning them into entries already. Right? So maybe what we do is we store the entries. I guess the question is, you know, in the I'm really kind of bugged by this feature of Zed lately. If you open a file and don't edit it, it'll like, and then you switch to another file, it'll replace that same tab. Maybe I'll do this and go nurse. No, okay. Anyway, you should be able to find entries in the nursery as well. So there's lookup, right? But it's looking like up here in do add. Ah, no, okay. So in the in-memory representation, they're keeping the actual value. Okay. So we don't have to care necessarily about exposing the entries outside of the nursery. That's good. So this is going to be key is vac8 and value is vac8. The other thing though is this is probably gonna, we're not gonna expose that, but let's say this is value, because we're going to have to have deleted as an option, and let's look at what else might need to be in there. We're not using expiration, but we need to have space for it. So let's say plain is a vac8, and we'll say deleted is an option, and then maybe we'll do time stamped is another option, but we're not going to implement that yet. Some time value. We're not going to do that right now. But then this can be, we can have operations like add, and I think that there's a delete. Let's see. Interesting, there's no delete. I wonder if, yeah, it's just that the whatever calls this will pass a tombstone. We can make a better API than that for, excuse me. Okay, path is not size, so I probably want path buff. Okay, so that's a slice of a path. So I'd either need to borrow it or use a path buff. Let's just say path buff. It's fine. Okay. All right, so now we can construct a nursery. We will need to deal with recovery. But let's do the green field, the golden path first. Okay. So this should return, and we kind of defined our own error over here in format. I'm wondering if I should promote that to the top level. Yeah, let's make a new file, error.rs. This feels like we were doing the okay, we're gonna say use create error star, and let's put this over here. All right, we need to have this mod error. Okay, and that should still work. Okay, so let's use create error star. Then we can say this returns a result of self, and we'll put in new variants, whatever we need here, for the different errors. Okay. So this is going to take a directory, which is as ref path, right? That's where to start, and there's going to be a min level and a max level, and these will go directly into our struct. Okay, so this is going to be a to-do deal with recovery, but let's get the file open. Let's pretend it's not there. So let log, and we're going to need open options, I think. File, okay. Let's say open options, new. Okay, and we want right, true, append, true. And what are the other things that it did? Opening the file. Raw is specific to Erlang. Is there a delayed write or a buffered write? Okay. I need to look at this and see what we can convert it into. Say 2 path buff. That's what we want. Right? So then we take ownership of it. Oh, this is impl as ref. Excuse me. The other thing that we could do is, put a generic out here. When we need the log file is directory.join. Why do you not know what that is? What am I doing wrong here? It is as ref path, right? Strings can deref to path, right? Yeah, like it's as ref that I want. I think it's probably I need to do dot as ref. Yeah. Okay. Fine. Picky. Okay. So let's look at path buff real quick. I think I wanted push path join. Yep. Yeah, you need to actually use the API to use the API. I was like, are you just going to magically deref it for me? Thanks. Okay. Okay, so now we're going to join, and we need to do nursery.log, right? And okay, that's infallible, so we're good there. And then we'll say open file. Okay. So now we have the directory, and let's just say this should have a question mark on it, right? Open should return a result. Yep. Okay, so now we'll do okay of self, and we have the log, right? Because that's the open file. Directory, min level, max level, and data is default. Okay, so we can open a nursery. Okay, so write is not necessary when it's append. Let's look real quick at the Erlang file open and the modes exclusive. Okay, so this is like saying it is created if it does not, the file is created if it does not exist. If the file exists, then it returns an error. So we probably need an open option that matches that. Okay, so we need create new. Yep. Let's put that at the beginning. Okay. It should not complain about append at that point because the main thing is we don't want to be able to scan backwards in it. Yeah. Okay. So let's put that there because that's the step where we'll do it. Obviously this, if it exists in this step, we're just going to bail. We'll return, some IO error. Okay. Okay, so we've got a nursery. There were some other sorts of accounting things that were done in here. Obviously, like this statement here isn't necessarily giving us all the fields that are in this nursery struct. So we need to look that up, and I think it's in here. Yeah. Okay, so here's everything. We've missed some things in our implementation. So we probably need to add these. So let's say total size is going to be U size in that case. We're counting bytes. Oops. Count is also going to be U size because we're counting entries. Last sync, let's ignore that for now. We'll just do entry by entry sync for the first pass. Step is how many steps. Yeah, let's capture these in there. U size and oops. Merge done. U size. And now we're going to have to fill in all of these things, but that's not a big deal. Let's hide the terminal. We're not using it. Okay, so total size starts at 0. Count starts at 0. Step starts at 0. Merge done starts at 0. Okay. Now, obviously, these are not used right now. And that's what Clippy's complaining about here. And we're not constructing those. So let's see if we can implement like a simple add without any of the potential side effects of adding something. And we'll see if we can get an entry written. That would be good. Okay, and now we're going to start to have to use these things. We might have to do like this. Maybe that might be a good step, is taking, constructing an entry and then doing the inverse of read. Do write and have it like give us a buffer. Give us a vec back. That would be pretty cool. Now, it's not going to be, all this. We're going to have to look at what the Erlang code does again. There was this util CRC wrap stuff. Where is it? CRC encapsulate. Okay. So right, we'll basically be implementing this, but on the entry struct. Okay. Interestingly, I think we'll be able to implement this knowing the size of the buffer we need at the outset. Okay. So let's do right. And I don't think we want to have it write to a file. I think what we want is, maybe we'll call this encode. And this should return a vec of U8. So we just want to encode the entry to bytes. In our case, it'll be key value or deleted for the nursery. So okay, so we want to I'm going to do it the dumb way first. And we're not going to bother with pre-allocating this vec to the correct size. That would be an optimization. We'll just push stuff into it. Yeah, so if there's no timestamp, which there won't be in any of ours, but we'll do this one, right? Okay, so let's do, and this needs to be mute. And we'll return output. We're going to push, this is tag kv data, right? And then we're going to do, it is the size of the key as an unsigned integer. So we're going to have to say, like, let key size we say if timestamp is none, do this, else. Let's just go ahead and handle this case because we kind of need to. Push tag kv data 2. Okay, so the key size is going to be key.len what we need this to be is I need to convert that to a U32. It's not safe. I need to write that here for future reference because otherwise we could be could be in a bad position. So and then we need to get the 2 BE bytes, right? So this should give us a, this is U84, okay? Key size. And again, we're using big endian. Sucks. Okay, so then we write the key size, and then we write the key value. Oops, I keep flipping the wrong thing. And then if it is okay, so interestingly, in this case, the timestamp comes before that. So what we could do here is go, let's see if the code action will refactor. Replace if with match. Okay. That's not what I wanted to do. None. And this is some timestamp, right? We'll do output.push ts. So this one, in this case, this will be a U32, right? 2 BE bytes. And this is not push. We want to extend. Okay. Okay, so there's our key value entry. So now we can, from our nursery, we'll need to handle these too, but from our nursery we could construct a key value entry with the correct stuff in it, and then write out the binary format, which can then be CRC32 checked and stuffed into the log. Not checked, but like wrapped, right? So let's go ahead and implement these other things, and then maybe that'll be time to wrap up. Okay, so similar thing here. If we match timestamp, and I want to reorder these. I prefer some first. Honestly, let's actually replace match with if let. Yeah, I like that. Okay. And we're going to do something similar here. If let. And this will be, the tag is deleted too, right? And then we've got the timestamp again, and here we'll do tag deleted. And then we do a similar thing here with the key size. Oh no, interesting. It doesn't have the size. Why? Why is, oh, I guess it doesn't have to split it, right? Okay, so we'll just do output extend key. Easy enough. Okay, and then for the pause len, we put the two things and the key. Okay, that's easy enough. And there's no branching here, so in this case, push tag pause len 32. And then we'll output dot extend and block position to be bytes. Output dot extend block len to be bytes. Output dot extend key. Okay. What are you complaining about? I need a return statement. Fine, just do that. My problem of doing multiple other languages in my day job is I sometimes let the idioms bleed over. And since we're not doing early return there, obviously we want output as a result. Okay, so, you know, if we were being a bit more careful, we could pre-allocate this. Honestly, it doesn't matter at this point. Like, if we find that this function is causing a bunch of like irregular allocations, or you know, this vec starts too small and has to grow again. Yeah, you're right. Writing let in JS not because it's the right choice, but because you're so used to writing Rust. Yes, it happens all the time. Very true, Chris. Okay, so let's go back to the nursery, and let's do add. Okay, this is going to have to take mute self, and we want a key, which is a vec u8, and a value, which is a vec u8. Okay, so following the pattern that we were doing over here in the Erlang code, let's look at do add. This is the internal bit. Okay, so it's encode the entry and add it. So in this case, I want to make separate add and delete. Maybe that's not necessary. Maybe we should allow, like, expose this value enum. But let's do unfortunately, with the way that the entry is defined, you know, these are not borrowed, they're owned. I'm going to have to clone. The other option, I guess, could be, oof. And I mean, the reason why they are owned versus what we had before with them being references was that when we're doing read and we're doing the actual file operations and we're not pretending like the whole file is in memory, we're not actually pulling the whole file in memory, then we need buffers to insert the data that we're reading out of the file into. So I think this is going to be a little bit of a source of friction for us, because ideally we wouldn't want to clone this just to create an entry that we can encode. It does make sense, I think, from a code organization perspective, to have the encoding be in, like, associated with this this enum. But the fact that these, we can't have like this being either evacuate or could we? We could. All right. Let's not worry about it for right now, but I'm going to write a little idea here and say, could we make entry generic over vec u8 and slice of u8? Because if we could, then we could say that this is like, I don't know, just t, and this could be t, and then only implement entry t for vec u8 for reads. Obviously that'll change if we switch to mmap at some point. And then it could be, you know, encode could take both an owned version, and maybe we name it encode owned, or encode borrowed, and you could give it slices. Anyway, for now, if we want to complete this today, our nursery, it's going to have to copy these. So let's make an entry, keyval. Can we do that? Okay, use create format entry. Okay. And timestamp is none. Okay. So now we need to do again, this bugs me. Let's go ahead and say encode on that. Now, the interesting thing here is maybe we could have it consume. It doesn't need to. Okay, so now we have the binary, like, entry into that we'll put into the file. When I say the file, this is the nursery log, right? The odd thing here is, like, this function that we were looking at earlier, crc232 encapsulate. Oh, so actually eventually calls this crc encapsulate. So we probably need to, yeah. So we need to have it prepend and then add tag end on the back side. Okay. Now we can actually do that ourselves, right? Interesting to remember, the prepended size here does not include this extra tag. Okay, so let's do the CRC bits here. It might make sense to. No, let's do it over here. Okay, so let's call this entry. Oops, rename that. Entry. And then we want to do, rather than returning an entry, and we're going to say back with capacity. We want entry.len plus 9, right? Because we have 8 bytes for the size and the CRC32, and then also the tag n byte. Interestingly, we could compute that up at the top, but if we know how many bytes it's going to take. Future refactor. Let's put it to you in here. Refactor to pre-allocate the entire encoded version with size CRC tag. Okay. All right, so now we're going to do, we're going to say entry.len as U32. Again, here's another issue where we are running into potential problems. And here we're going to do CRC32 fast hash entry, and that should return a U32. Yep, easy enough. Extend, and okay, and this needs to not be push, because push takes a single character or a single byte. We need extend on all these. And again, here I'm doing a bunch of reallocations. It's dumb. And then we'll push tag end. Okay, so now we return output. I kind of wish there were easier way to express this. Again, like missing Erlang's binary construction and matching. So nice. It would be way nicer to do it like that. But here we are. Okay, so now we've got the binary entry, and we want to put this also in the local, like the in-memory cache, right? So let's do self.data. Insert key, and then here we want to do value plain, right? Because it's not a tombstone. Okay, so now we can go back here and see what they do next. Do add. Okay, so now it's write to the file and sync it. And I think I need to import standard IO, right? It's not auto imported. Oh, it's log. So we want to write that entry to the log. Then we want to do self.log.sync. The question here is this f-sync or is this f-data-sync? It's data-sync. Okay. Sync data. Now here, this needs to be return a result of that, so we can do this. We're not handling the last sync yet, but we definitely need to. I think we can factor this out at some point. But if we're adding, we need to handle the incremental merge. And at this point, I think we will just update the total size and the count. Right? Now the count, the thing is the count is actually the same as data, the size of the entries in data. So I wonder if we even need to track that. Let's not. Let's remove it. Okay, and then finally, let's look at that. Do inc merge again. Right, so here we're just adding one to step, and then let's do a to do invoke incremental merge self.step plus equals 1, and then we'll return OK. Okay, that's not too bad. Now this we'll want to factor out into its own function. We'll obviously have the incremental merge to deal with. There's a nursery log in here. I don't know that I want to do recovery right now. Not today. I think this is a good place to leave it. Obviously, we haven't exercised any of this code yet, but I think next time would be a good time to look at recovery of the log, the nursery log. Look at, can we abstract out this incremental merge thing? Maybe can we remove some of these extra allocations, both here and in the encoding of the entry. I think that would be a good place to pick up next time. Okay, so we're gonna add source. Let's look at the different things. Okay, this is session 4. Move error to its own file for reuse, and start the nursery. All right. Good stuff. That is all pushed up to GitHub. Reminder, if you are still watching, thank you, Isaac, for coming. Thank you, Chris, for coming. Anyone else who was here. We're going to do YouTube next time. So hopefully the UX will be a little bit better, and we'll get a little bit more reach. Again, thanks for coming, and see you next week. Cheers.